Welcome, dear student. Good morning to everyone. In previous period, we discussed about examples on Pythagoras theorem. Today, we discuss about extra examples on Pythagoras theorem and different concepts in new chapter number 3, circle. Let us start. As in previous period, we discuss about that examples we studied in previous period. Then next example we discuss here. Find the length of side and perimeter of an equilateral triangle whose height is root 3 centimeter. Here equilateral triangle means as samabhuj trikon, means three sides are congruent. We draw here triangle A, B, C. This is an equilateral triangle and height is given. Draw height from point A. AD is the height and its length is root 3. Triangle ABC is an equilateral triangle. Therefore, three sides are congruent, that is AB is equal to BC is equal to AC. All sides are congruent. Each side consider x, here x, here x, and here also we get x. Then here height is perpendicular to BC. AD is perpendicular to BC and therefore height of an equilateral triangle bisect base. That height bisect the base means which parts are congruent as, that is BD and DC are congruent and each part is how many times big part as height bisect the base means two parts are similar and both parts are how many times the big part, that is half. Value of BC is x and divided by 2. Here we get x upon 2. Then we consider this triangle, and this is right angled triangle. In right angled triangle, triangle name is triangle ADB. Which theorem we can use? As good answer given. Savan, give correct answer. Yes, by Pythagoras theorem. Yes, by Pythagoras theorem, hypotenuse square means AB square is equal to base square means BD square plus height square means AD square. Yes, therefore value of AB is x, that is x square, is equal to value of BD is x upon 2 and bracket square plus value of AD is root 3 and its square. Yes, good answer given. छान अगदी उत्तर द्यायला लागलाय. Therefore, x square is equal to square of that term, that is x square divided by 2 square is 4 and plus root 3 square is squaring of root 3 is 3. Then remove denominator by multiplying that number. 4 multiplied to each term. What we get? Yes, that is 4 into x square is equal to 4 into x square divided by 4 plus 4 into 3 multiplying by 4. Then 4 1 is 4. Therefore 4 into x square, 4x square is equal to, here only x square remaining, and plus 4 3s are 12. Then 4x square plus x square taking on LHS side, it becomes minus x square and is equal to 12 remaining. Therefore tail here subtraction, 4x square minus 1x square, what we get? That is 3x square is equal to 12. Therefore x square is equal to 12. 3 multiply, here divide. 3 1 is 3, 3 4s are 12. Therefore, x square is equal to 4 remaining. This implies that take here root root of x square is x and root of 4 is 2, and by taking root, and this is find the length of side. Therefore, length of side is equal to 2 and centimeter is given. That is the answer. Yes. Then second question is perimeter. Perimeter of an equilateral triangle is equal to, what is the formula? Tell here. Yes. Formula is 3 sides are similar, 3 into side is equal to 3 into value of side is 2 and multiplication is 6 centimeter. That is the answer. Yes, good answer given. छान उत्तर द्यायला लागलाय. Then मेथड सेकंड, दुसरी एक पद्धत आहे सॉल्व करण्याची. गिवन इज height of an equilateral triangle is equal to, what is the formula of height? Yes, height's formula is root 3 divided by 2 into side. That is the formula of height of an equilateral triangle. Yes. Therefore, height is given. Height is root 3. Root 3 is equal to root 3 divided by 2 into side. Therefore, what is the next term? That is root 3 into root 3 upon 2 taking on LHS side. It becomes, tell here. That is, to divide, here multiply, root 3 multiply, here divide, and is equal to side remaining. Yes, छान उत्तर द्यायला लागलाय. Then root 3 get cancelled. Therefore, only 2 remaining. 2 is equal to side. Therefore, length of side is equal to 2 centimeter. And next question is perimeter is equal to 3 into side. 3 into side is 2 and multiplication is 6 centimeter. This is the second method. Second method is short. This method used for 2 marks and this method, first method, used for 3 marks. In this way, we can solve that example. Problem set second and fifth number example. The next example we discuss here. In triangle ABC, segment AP is a median. If BC is 18, AB square plus AC square, its value is 260. Find AP. Yes. Here we draw triangle. Triangle ABC is given and median is AP, means P is the midpoint of segment BC because AP is the median. Segment AP is a median of triangle ABC. Therefore, P is the midpoint, and which are the two parts similar? That is, these two parts are similar. Therefore, BP is equal to PC is equal to these two parts. How many times of big part? Here, P is the midpoint, two parts are similar, and these two parts are how many times the big part? हे दोन भाग सारखे असतील, ते मोठ्या भागाच्या किती पट असतील? Yes, half of BC is equal to half into value of BC is 18. 2 1 is 2, 2 9s are 18 is equal to 9. We get answer. This value is 9. This also 9. Then, if median is given, then which theorem we can use here? Tell the name of theorem. Yes. Therefore, by yes, by Apollonius theorem. Yes, good answer. What we say? AP is the median, then left side is AB, right side is AC. Squares addition, that is AB square plus AC square is equal to twice median square, that is AP square, plus twice one part square, that is BP square. Yes, good answer given. छान उत्तर द्यायला लागलाय बघा. AB square plus AC square, its value is given. Value of AB square plus AC square is given here. That value we substitute. 260 is equal to twice AP we find out plus 2 into value of BP is 9 and its square. Therefore, 260 is equal to twice AP square plus 2 into 9 square tail here. Yes, that is 81. Therefore, 260 is equal to twice AP square plus multiplication tail here. That is 162. What is the next term? As 260 plus 162 becomes minus 162 and is equal to twice AP square. Tail here subtraction. Yes, good answer. And subtraction is yes, good answer. 98 is equal to twice AP square. Therefore, AP square is equal to 2 multiply, taking on LHS side, it becomes divide. Yes, that is 98 to multiply, here divide. Therefore, half of 98 tail here. Yes, good. 49 is equal to AP square. This implies that taking root of 49 is tail here. That is 7 is equal to root of AP square is AP, and by taking square root, therefore AP is equal to 7. That is the answer. In this way, we can solve that example. As here we take one point and take another point on distance 2 centimeter, means here or here or in this way. Here we get at 2 centimeter, we get many points on distance 2. Here O is 1 point and we take another point at distance 2, but there are many points at distance 2, then that set of points are called as circle. And today we discuss about chapter number 3, circle. Here one circle, its radius is 2 centimeter, and here another circle, its radius also 2. If two circles radius are similar, then that circles are called as tail here. That is congruent circles. Then here center, and here one circle is drawn, then another circle also we drawn here. Small circle, its center is O. Big circle, its center also O. If circles having radius same, then that circles are called as concentric circles. Means एक केंद्री वर्तुळे. Here एकरूप वर्तुळे. This is circle. And if here we draw circle and another circle also we draw here, then these circles are intersect in two different points, and these circles are called as intersecting circles. Means छेदणारी वर्तुळे. Then in previous year in 9th standard you study one theorem. Point O is the center and AB is called as chord. A perpendicular drawn from center to chord, that is OM, is perpendicular to chord AB, and therefore a perpendicular drawn from center to chord, then that chord bisect. Means AM and MB parts are similar, and its converse also you study in 9th standard. AB is the chord and M is the midpoint. O is the center. Center O and M is midpoint of AB. Then therefore we can say that midpoint and center joining the segment, that segment is perpendicular to chord AB. These two theorems we study in 9th standard. They here a line intersect circle in one point, then that line L is called as, and another line intersect circle in two different point, line N. These are the two lines. Then we can say that for line L what we say, and for line N what we say. Yes, line L is called as tangent. Means sparshika, and line N is called as what we say here, that is secant. Means छेदिका. This is tangent and this is secant. Here O is the center, then OA segment is called as segment OA is called as segment OA is called as radius, and here we get angle 90 degree, means segment OA is perpendicular to line L, means radius and tangent perpendicular. What we say? Radius is perpendicular to tangent. Yes. The next part we discuss here, that is here one circle we draw here, then O is the center and point A is present in exterior part. Then from point A we can draw tangents. How many tangents can be drawn? First we draw here like this, and second we draw here like this. Means how many tangents can be drawn from exterior point? There are two tangents can be drawn. Then here suppose point B and here point C. Then tangent is AB. Tangent is line AB and line AC. These are the tangents. Then tangent segment is equal to segment AB is called as tangent segment, and another is segment AC is called as tangent segments. Line is called as tangent and only segment is called as tangent segments. And here we get one theorem, tangent segment theorem. This is very important theorem asking for board question. Tangent segments drawn from an external point to a circle are congruent. These tangent segments are congruent. That is the theorem. Theorem is tangent segments drawn from an external point to a circle are congruent. In solution, that theorem we can prove in 4 parts. First is as given circle we draw here. O is the center and external point is A. From A we can draw tangents. First tangent, and here also we draw tangent, that is second tangent, as here touching point is B and here touching point is C. Center is point O and S. Tangents are, which are the tangents? That is line AB and line AC are tangents. Then next part is to prove. What we prove? Tangent segments are congruent. Which are the tangent segments? That is segment AB. Congruent. Another tangent segment is AC. Yes. The next part is construction. हा बोर्डाला विचारला जाणारा हा थेरम आहे. Yes. Join segment OB, segment OC and segment OA. Join segment OB, segment OC and OA. The next part is proof. Yes, we prove here two sides are congruent, two segments are congruent. Tell the name of triangle of segment AB. Segment AB असणारा triangle, that is triangle ABO, and segment AC असणारा triangle, that is triangle ACO. When we say that two sides are congruent, साइड कॉन्ग्रुएंट आहेत असं आपण केव्हा म्हणू शकतो? इफ two triangles are congruent, then corresponding sides are congruent. For that purpose we show two triangles congruent. बाजू एकरूप सिद्ध करायचे आहेत त्यासाठी त्रिकोण एकरूप दाखवले पाहिजेत, तेव्हा आपण म्हणू शकतो बाजू एकरूप असतात. Here OB is the radius and OC also radius, and radius are equal, means both segments are congruent. That is the first condition. segment OB congruent segment OC, and reason is radii of same circle. Plural form of radius is radii of same circle. Then in both triangle, OA is the common side, therefore segment OA congruent segment OA, because this is common side in both triangle. Segment OA congruent segment OA because common side. Then this is radius and this is tangent. Radius and tangent are perpendicular to each other. Here this is radius OC and tangent AC are perpendicular to each other. Means we get 90 degree, and equal measures of angle are congruent, means angle OBA congruent angle OCA, because each 90 degree, and reason is radius perpendicular to tangent. Yes. Therefore, we can say that two triangles are congruent because three conditions we get here. Triangle ABO congruent triangle ACO, and tell here reason. Yes. What is the reason? Which test? Here 90 degree and opposite side of 90 degree is hypotenuse. This is hypotenuse and side, that is hypotenuse side test or theorem. Therefore, if two triangles are congruent, then corresponding sides are congruent, that is segment AB congruent segment AC, and reason is corresponding sides of congruent triangle. These are the corresponding sides of congruent triangle, and that is to prove here, hence the proof. In this way we can prove that theorem, and this is important theorem asking for board question. बोर्डाला हा विचारला जातो. Dear student, today we discuss about examples on Pythagoras theorem and different concepts in circle, and one important theorem, tangent segment theorem, also we discuss here. The next part we see in next period. Thank you. Dear student, today we discuss about examples on Pythagoras theorem and different concepts in circle, and one important theorem,
tangent secant theorem also we discuss here. The next part we see in next period. Thank you.